Welcome to Slope and Writing Equations of Lines, Part 2. Last lesson, we were all about slope, really going over the definition, how to find it, what it means in terms of the graph. And this lesson is going to focus on writing equations of lines. To begin with, I want to ask you this question. How many lines go through both the point 3, 2 and the point 5, 8? So if you were to plot those 2 points, how many lines could you draw that go through both of them? Now, I give you a hint here. Try to draw them if you aren't sure. Most of us are visual learners, so most of us do better when we're able to picture something. So take a moment. I'm going to pause the video in class, and I'm going to give you a chance to mull over this problem and try to sketch something out. And I have the option of putting graph paper on this, so I decided to take advantage of it. All right, so let's just model what this would look like if you're not sure. Now, you might remember this, and you might remember it from geometry, because there's, I think, a postulate that goes with this in geometry. But if I were to try to picture it, the point 3, 2, I go right 1, 2, 3, and up 2. And then 5, 8, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And the question is, how many lines can I draw that go through both those points? So we'll start with the obvious one. There we go. I draw that line. And now I'm kind of coming up dry. I can't seem to draw any more. Now somebody might say, well, you could do this, but we want to remember the definition of a line. So that's why our definitions are important. In math, lines are always straight. So this line that's kind of bending and waving and it's steep right here and it's not as steep here, that's not a line. In math, we would call that a curve. We'd actually call lines curves as well. Curve is like a broad umbrella term for just about anything you could graph. We call it the curve. But it's definitely not a line. So if you start trying to do this out, you will come to the conclusion very quickly that you can only draw one line through any 2 points. In geometry, there's a postulate that says 2 points determine a line, which just says, like, in order to draw a line, you have to have 2 points. And if you have 2 points, there's only one line that will go through both of those points. Very, very key idea, because it sets us up for, oh, look, I got notebook paper now. It sets us up for being able to write the equation for a line. In order to write the equation for a line, you only need 2 points. Okay, so to write... No, I'm not going to say an equation. To write the equation for a line, all we need is 2 points. Because there's only one line that goes through 2 points. So that's all we need. If we have 2 points, we have everything we need to write the equation for a line. Okay, so that's going to bring us to something called a slope-intercept form of a line. And there are different ways of writing equations of lines, slope-intercept form for a line. This is probably the most I don't know, like popular form for the equation of a line. In this class, I actually really try to keep you guys to slope-intercept form. We'll do a little bit in standard form. If you were taking Algebra 2 at the honors level, they would spend more time with slope-intercept, something called point slope. I barely will even touch point slope if I'll do it at all, because you don't need it. You can do everything you need to do with a line if you know slope-intercept, and then probably standard. So slope-intercept form is the y equals mx plus b, and it is named that because there are 2 numbers in it. The number multiplying the x is your m value, that is the slope. And then the number outside here is what's called the y-intercept. So that's where it gets its name, slope y-intercept form. We're going to explore that in a little bit, but here's the general strategy that we are going to use. Okay? General strategy. And we'll mull this over, because if you get the strategy, it's like our game plan. What are we going to try to do? We are going to find m and b. These are numbers, okay? The x and the y are variables. We are going to find the m and the b. We're going to find the number values for m and b. Find the m and b. And plug them in to the equation. Okay, now I'm going to say this. The answer should be something like this. Y equals, what did I put here in my notes? 5/3 x plus 2, I think it's a minus 2, or like y equals like 2x minus 4. So when you're done with the problem, what your answer should look like is you should have a y, you should have an x, you should have a number where the slope is, and you should have a number where the y-intercept is. Now, there will be a couple of exceptions to that. If the slope is 1, you would not typically write 1x. If the slope is 0, then the x is going to drop out. And if your y-intercept is 0, most people do not write plus 0. So there are a couple of exceptions to that. But what happens very often in these problems is that students do not finish the problem. They find the m and the b and then they stop. Or they'll plug them in, but they won't have the x and the y. They will keep some numerical values in there. So I want you to be really clear on what your answer is supposed to look like. If you are asked to write the equation for a line, okay, remember that is the title. We're writing equations of lines. So if the directions say write the equation for a line, your answer should look something like that, probably with different numbers. So I'm going to give you the steps, and we're going to work the hardest version of the problem first, and then I'm going to back you up, and we're going to work on easier versions, but we're going to tackle the worst case scenario first. You can hang with that, then you'll be good for the rest. So for example, we're actually going to work with the class discussion problem from the beginning. I have here the equation. I have a line, obviously, and it was made by the points 3, 2, and 5, 8. What we're going to find is the equation that goes with that line. And I'm going to break this down into steps. I'm going to do my best to color code these steps for you, and I'll see you at the end. So step number 1 is to find the slope. And we covered that last class, so we should be good to go on finding the slope. If you don't have the slope, the first thing you're going to do is find it. Remember your formula for finding the slope: y2 minus y1 over x2 minus x1. It doesn't matter which order you pick them in, but I do notice looking at this that the 5 is bigger than the 3 and the 8 is bigger than the 2. So if I have to subtract them, I'm going to try to subtract them in a way that keeps them positive. So I'm going to do 8 minus 2 over 5 minus 3. Make sure again that you're lining it up correctly. So the y's go in the numerator, the x's go in the denominator, and if I'm going to start with the 8 for the numerator, I have to start with the 5 for the denominator. You can't just switch them around. If you have a hard time with that, do what I did in the last lesson and label them like x1, y1, x2, y2. And just label them, because that usually will fix that mistake. 8 minus 2 is 6. 5 minus 3 is 2. And 6 divided by 2 is 3. And I'm just going to recopy that. And step 1 is done. So if you practiced with finding the slope, then this becomes easy because you've already mastered this skill. So step 1, find the slope. Slope is 3. Step 2, okay? This is where I get around using other forms of the line. So we are going to borrow a point for x and y. Okay, so we're going to choose a point and borrow it. Now, the key thing with borrowing, if you were to borrow a pencil from me, which we're not really doing during COVID because we don't want to be handing lots of stuff back and forth, but the idea is you borrow a pencil, and then when you're done using it, you're going to give the pencil back. So we're going to borrow a point to get the X and the Y, but when we're done with the X and the Y, we're going to give the point back. We're going to give it back because we don't actually want those numbers. So you can choose either point. Either point is fine. I'm just going to choose the 3, 2, but not because it's a better point. Like, you can pick whichever point you want to borrow. So if you're feeling adventurous and you're taking the notes at home, then go ahead and borrow the 5, 8 and just kind of work this problem out with the 5, 8 and you'll end up in the same spot. Now, remember that your point is made up of the X and the Y. So in this case, the X is 3 and the Y is 2. And again, we're borrowing these numbers. We're borrowing the 3 and the 2. We're going to give them back because my answer is supposed to have an X and a Y in the answer. So I'm eventually going to give those back. Step 3, we're going to plug in X, Y, and M. Plug in X, Y, and M. So we've got this form, y equals mx plus b. I have a number that I can use for y. I'm borrowing it. I'm going to give it back, but it is a 2. I know my m. That was the first step up here to find the slope, so I have a value for m. I have an x. I have the 3. Again, I'm borrowing the 3, so I am going to give that back, but I do have it. And then I don't have anything for the b value. Okay, that's the one thing I don't have. But remember our strategy. Find m and b. We already found m. Guess what we're finding now? Oh, that would be b. So that brings us to our next step. Solve for b. Now remember from last unit, the directions solve for mean get the b by itself. In other words, solve this linear equation. So I'm going to bring down the 2. 3 times 3 is 9 plus b, and then I will subtract 9 from both sides, and I get -7 is equal to b. So far, so good. So remember my strategy. Find m, find b, plug them in. We only have one step left. We found m, we found b. I'm out of colors on my palette, so I have to go, let's go back to the blue. And my last step is rewrite the final answer. So rewrite final answer. So here with the m and the b. So this is what it looks like. I'm really running out of space here. So we have y equals mx plus b. And remember, the final form of our answer should be y equals a number times x plus a number or minus a number. I'm going to give back the y and the x. Remember, borrow. We borrowed the 3 and we borrowed the 2, but I don't actually want to keep them. So I'm going to give back the 2 and get my y back. The m we're keeping, okay, we know the m value is 3. The x was borrowed. So we're going to give back the 3. We don't want that 3 to stay there. We're going to give it back and bring our x back. And now I have a number for the b. The b value is a -7. You could also, and I really am cramped for space here, but most people don't like plus -7, so they would write -7 instead. And remember the final form, what? Okay. The final form of the answer. You know what? It's not going to let me box this in. Okay. Final form of the answer should be y equals mx plus b, where you have a number for m and a number for b. And I'm sorry, that glitched. I grabbed the screen at the wrong spot, and suddenly I was in Facebook. And you can't tell that from this video, but I was. All right, so that is the hardest version of writing equation of a line problem. The only thing I can do to make this harder is to give you negatives or fractions for the numbers. That's it. I can't make the algebra any harder at all. Like the algebra just isn't, algebra is not harder than that. So if you need to, take a moment, pause on this, and just reread these steps. And I do try to color code it so you can see what each of the steps looks like when you actually carry it out. And we're going to go on to our second example. What I've done in the upper left-hand corner here is I just recap the steps. So this is a shorthand version of the steps that I gave you before. And the goal is for this to become automatic. I don't want you to have to think really hard about these steps, but until you're at the point where you don't have to think too hard about them, what I expect you to do when you have your homework is you're going to have your notes out in front of you and you're just going to follow the plan. Like I'm giving you the plan. Follow the plan and you will get to the destination. I do promise you that. So for this second example, this is actually an easier version. We are going to have a slope of 3 and our line goes through the point 1, 5. Now, the reason this is easier is because if you look at the first step was to find the slope. In this problem, I am told that the slope is 3. So this one's a little bit easier because the first step is already done. I'll go ahead and I'll just write m equals 3. Yay, first step is already done. So we didn't even have to do that first calculation. Now the second step is also simpler. Borrow a point for x and y. Well, I only have one point there, so you don't even have to make a choice. You're going to use the point 1, 5. The x is the 1 and the y is the 5. So we have x is 1 and y is 5. And remember, this is being borrowed. So we're borrowing the 1 and the 5. We are going to give them back. Next step, plug in for x, y, and m. So what are we plugging it into? That slope-intercept form. I have y is equal to 5. I have m is equal to 3. X is equal to 1. And so all I've done is I've taken m, x, and y, and I've plugged them in. Again, work top to bottom. Most of you do, but some of you are stubbornly, like you're working from left to right. Work top to bottom. I should be able to see exactly what you're substituting in without having to backtrack because you're working like left to right, and I'm backtracking into the problem. Top to bottom, top to bottom, top to bottom. Next step, solve for b. So 3 times 1 is 3, and then I'm going to subtract 3 from both sides, and I get b is equal to 2. And don't stop. This is a spot where a lot of students will stop, and that's not the what you're being asked to do. You're being asked to write the equation of a line. So the last step is rewrite the final answer. I'm actually going to do something wrong here, so I'm going to clearly label this as a mistake just because it's a common mistake. So what a lot of students will do when they do the rewrite step is they will do this. Okay, and the problem with that is that it doesn't take the right form. Remember, the form of your answer is supposed to be the y and the x. And remember that you're borrowing a point, and a key thing about borrowing a point, borrowing something, is that you give it back. So we borrowed the 5 and the 1. We want to give that back. That should not be your final answer. It's the wrong form, and you haven't given back your x and your y. So your final answer would be y equals, you're going to keep the m, you're going to give back the x, and then you're going to have your b plus 2. And that's what your final answer should look like. I'm going to deviate off the notes just a little bit because I am going to show you just one more version of the problem that you might see. Okay, this isn't even in the notes, but what happens with students sometimes is The problems can get so easy that students think that they're missing something and they think it's harder when it's actually easier. So I do want to address this. This one, you're told the slope is -4 and the y-intercept is the point 0.05. If you think about, go back to the general strategy here, okay? Like there's a reason I put this up. Find M and find B. In other words, find the slope and find the y-intercept. In this problem, you're actually given both of them. You are told that the slope is -4. And we haven't really talked about the 0 here or the definition of y-intercept. We will talk about that. What? So help me, I don't know what I did with the writing, but I hope these are the same numbers because I was making them up on the fly. So we're told the slope is -4. The y-intercept in this case is just the 5. And I hope it was a 5 that I had up there a second ago. So this one, you're actually told the M and the B, so there is literally nothing to do. The slope, the M value is -4, and the y-intercept is a +5, and that's it. So if you're given given the slope and given the y-intercept, please don't overthink it. You don't have to do the first, second, third, or fourth step. You just skip right to the very last step. So I just wanted to address that. Last thing for this lesson, I'm going to put a practice problem, and I'm going to ask you guys to write the equation of the line going through those points, and then we will go over it together. So here is your practice problem. I would like you to write the equation of the line going through the points 4, 1, and -2, 4. Remember, we established at the beginning of this lesson, there's only one line that will go through those 2 points. Also, I want to draw your attention to the directions. Write the equation of the line. Your answer needs to look like this with a number for the M and a number for the B. And I will give you one last little hint thing here is that so that you don't think you've done something wrong, the slope will be a fraction. So don't freak out about that. If you get a fraction, it means you did it right. So if we're doing this in class, we're going to stop the video right here and we'll give you time to look at it and we'll go over it together. If you're watching the video at home on your own to make up the lesson, just keep watching and I will go over this problem. So for those of you following along at home, or who just want to see the problem done out again, let's go through this. We'll go through the 5 steps. Again, follow the plan and you will get to the destination. I promise you, you will get to where you want to go if you follow the plan. So step number 1 in the plan is to find the slope. So I have 2 points. I'm just going to throw these out here as x1, y1, and x2, y2. And here's my formula for the slope. It is y2 minus y1 over x2 minus x1. y2 is 4, y1 is 1, x2 is -2, x1 is 4. I subtract that, I end up with 3 over -6, which will simplify. Now, 3 over 6 simplifies to 1/2. Now, the negative in the denominator, you're welcome to keep the negative in the denominator. I prefer to have my negative in the numerator. And if I have time on this video recording at the end, I'll show you why you can move that, okay? Why you're allowed to move that. But for right now, I'll just, tell you you can move that. All right. Next step is we need to choose a point for the x and the y, and I am going to pick this point because I'm going to try to avoid the negative if I can. Sometimes you won't be able to avoid the negative, but if I have the option of something with a negative and something without a negative, I'm taking it without the negative. So I'm going to borrow x equals 4 and x equals y. We're going to give that back later though. Now we're going to plug those in to y equals mx plus b. So I have a value for y. I'm going to use 1. Then I have -1/2. X is equal to 4. And then I have the plus b. So we have 1 equals -1/2 times 4 plus b. You are welcome to use a calculator to do that. I hope you don't have to, but if you do, it's okay. You can. It's not against the rules, okay, to use your calculator to do that. Half of 4 is actually 2, and then because it's a negative times a positive, we'll end up with a negative 2. And then to undo your negative, I'm going to add 2 to both sides. And I get 3 is equal to B. And then that last step is to rewrite the final answer of your problem. And we're going to give back what we borrowed. So we're going to bring the y back. We're going to keep the slope of negative 1/2. Seriously. Negative 1. Negative 1/2. X, and then we're giving the x back, and then we have 3. So your final answer should be y equals negative 1/2 x plus 3. I've got about 4 minutes left on the timer. So while I have that, I'm just going to quickly go over like that movement of the negative, because I don't want you to just take my word for it that you can move a negative around. Typically you can't. You can't just move symbols around in math. There has to be a reason for it. So if you had 1 divided by negative 2, that would be, if we did it like this, that would be 1 divided by negative 2. We know from our signed numbers that if you take a positive number and you divide it by a negative number, it'll give you a negative. A positive divided by a negative is a negative. And 1 divided by 2 is 0.5. So if you had 1 divided by negative 2, you can do this on your calculator too if you just don't trust me, if I seem sketchy to you. So that would be a negative 1/2. Now, if I have the negative in the numerator, that's negative 1 divided by 2, and we know a negative divided by a positive gives you a negative, and 1 over 2 is the 0.5, and what you should notice is that these are actually the same. If you wanted to, you could do each of these out on your calculator, and they're both going to give you negative 0.5. So you can move it. It's not wrong to put it in the denominator, but most of the time, most of us are more comfortable with having it in the numerator, so you can move it. Now, the other place you can see the negative is out in front of the fraction, and that's actually the same thing. That's like doing negative 1 divided by 2, where you've got the fraction bar acting like a grouping symbol. 1 divided by 2 is 0.5. And then the negative would come down. So you can actually see the negative in one of 3 places. You can see the negative in the denominator, the numerator, or in front of the fraction, and they are actually all the same. So where you put the negative is really up to you, what your preference is or what you're going to do. A common mistake, though, when students see the negative in front of the fraction, is that they will want to put it in both places, like they think the negative goes with both, and it doesn't, because the negative divided by a negative would give you a positive, and that's actually going to change that on you. So I do see that mistake quite a bit. So I wanted to just address that in the live session in class. If I have time, I'll do the same thing, because I don't like just moving stuff. And if I ever do this, if I ever just move like I did over here, I just moved the negative, and you don't know why I did it, please, ask, post it in the help center, interrupt me on the live stream, make sure you get an answer to that. If I can't answer it right then in the middle of class, I will make sure that I address that. So there's no voodoo or magic happening. If I move something around, there's a reason I can do it. So that's the end of this lesson, and I will see you for the next one, which is graphing. We're going to do some graphing, and it's going to be the best thing ever. So I will see you guys next time.